Okay, let us see what are carbenes. Carbene is a general name given to any species where a carbon has positive as well as negative charge on the same carbon. This is the simplest example. The normal valency of carbon is 4. Here it is only 2. The two other valencies are compensated by the negative charge and positive charge. Consequently, this is extremely reactive, very fast reacting intermediate or species. Now, since this has both negative as well as positive charge, it will react with another species which also has the positive and negative charge. And we have seen that in alkene you can draw the resonance structures to give you a positively charged carbon as well as a negatively charged carbon. So therefore, there is a ready reaction between a alkene which has this positive charge, this negative. This is the more stable of the two resonance structures. So therefore, only this is shown. So this positive charge will react with the negative charge from the carbene. Consequently, the negative charge will react with positive charge. Now, what is the effect of this? The effect is you have introduced a CH2 group between the two carbons. So this is one carbon, this is another carbon. So the product formed is a cyclic one because both the carbons are now connected to one carbon which is CH2. And CH2 is methylene. CH3 is methyl. CH2 is called as methylene and CH is called as methine. Now note the spelling of methine. It is not methyne. YNE refers to triple bond and there is no way a triple bond will be formed with only one carbon. So therefore this spelling is methine. The pronunciation is same but spelling is different. So you have introduced a methylene group across the double bond or you have added a methylene to the double bond. In the process you are getting a cyclic structure. So the simple way, there are different ways you can generate a carbene. One simple example is you take chloroform, treat it with OH minus, simple base, NaOH, KOH, anything. What you get is a carbene. Now there are two chlorines attached to this instead of hydrogens. So therefore this is called as dichlorocarbene. This is simple carbene. Here two hydrogens are replaced by chlorines. So therefore it is called dichlorocarbene. Reactivity wise it is same. This and this both are extremely reactive because they are positively as well as negatively charged. Carbon is positively as well as negatively charged. So therefore it is very reactive. The negative charge will form a bond with the positive part of the carbon. Say in this case it is this carbon. And the negative part will form with the positive part. The positive part will be attacked by the negative part. The net result is you have introduced this CH2 across the double bond or between the two doubly bonded carbons. This is what is called as cyclopropanation. Formation of cyclopropane from double bond, it is called cyclopropanation of a double bond. Now if you react dichlorocarbene with a double bond, what you get is a geminal dichlorocyclopropane. Geminal refers to the same carbon on which both the chlorines are present. Vicinal means on the adjacent. So therefore these two chlorines are on the same carbon. So therefore this is geminal dichlorocyclopropane. So using different carbenes you can get different cyclopropanes. Now you compare the structure of carbene with that of carbonium ion, carbanion and radicals. Here you have one electron, here there are two excess, here it is one less, here two electrons less. Nowhere here you see both the charges. Consequently, these are less reactive compared to this carbene. Now, another closely related species to carbene is nitrene. Nitrene means the positive and the negative charge is on a nitrogen instead of carbon. So similarly, nitrines, carbenes, both are very reactive intermediates because they are highly deficient in valency. The normal valency of nitrogen is 3. Here it is only 1. The other two are represented by negative charge and the positive charge. So if you add nitrene to a double bond, you end up with a 3-membered ring containing nitrogen atom. Again, this is very useful reaction to prepare small rings which are heterocyclic or carbocyclic. Carbocyclic means there is carbon. Heterocyclic means one or more carbons is replaced by other atoms. Usually for us, we should take it as nitrogen, oxygen or sulfur. The three common heteroatoms which we encounter in drugs or different biological systems. So this is how the carbenes react. There are different ways again in which you can form them. This is just one example which is given of dichlorocarbene because it is the easiest. There are other methods also, but this is addition of carbene to a double bond is what is called as cyclopropanation, and this reaction is what is called Siemens-Smith cyclopropanation. These are the scientists who discovered this, invented this, and therefore their name is given to this reaction. So very useful for forming a 3-membered ring. But since they are very reactive, they also give some other reactions like insertion of hydrogen or some other reaction. So you get a number of side products also. But nonetheless, very useful method because you get very ready formation of 3-membered rings, either cyclopropane or containing a nitrogen.